there, Mr. Sutton here with the IM371 Part 2 homework solutions on Pythagorean Theorem.
For this one, we want to know if this triangle is a right triangle. They certainly didn't give us the little box symbol down there, so it could be a right triangle, but maybe not. To figure this out, we need to see if this satisfies the Pythagorean theorem, a squared plus b squared equals c squared. So when I'm plugging numbers in here, for a and b, I have to choose the shorter sides because c, the hypotenuse, is always the longest side of a right triangle. So I'm going to write here 45 squared plus 168 squared, and I want to know if that equals 175 squared. So I'll put a little question mark. Now I just have to evaluate each side and see if they match up. And for that, I will use the calculator. So let me first evaluate 45 squared plus 168 squared. That comes out to 30,249. Now let me see if 175 squared comes out to that. And I'm pretty sure it won't, because you're multiplying something that ends with a 5 by another 5, so you're not going to get a 9 as the last digit. But let's just see what it actually does come out to. So 175 squared comes out to 30,625. So it's actually not that far off, but as we can see here, those are not the same number. So therefore, because this does not satisfy the Pythagorean theorem, it cannot be a right triangle, so no. For this problem, I'm trying to find the area of this triangle to the nearest tenth. So to do that, in general, I need base times height. I've got the base of the triangle. I do not have the height. Fortunately, this is a right triangle, and we already have two sides. So we can use our Pythagorean theorem, a squared plus b squared equals c squared, to find that other side there, that height. Just so I have something to refer to it with, I'm going to label this as h. And I'm going to start by solving for h. Once I have that, I can use my area formula with the 6 here to get the area of the triangle. So Pythagorean theorem, I've got 6 squared plus my other leg here, my other non-hypotenuse side, h squared, equals my hypotenuse across from the right angle, 8 squared. That's my c value, 8. And then let's see here, I've got to get h squared by itself, so that's going to be 8 squared minus 6 squared, so 64 minus 36, and that is going to be, let's see here, 28. So now I need to take the square root of 28. And I have to round intermediate answers to the nearest tenth. So let me just round off the square root of 28 to the nearest tenth. So doing that on the calculator, I get about, let's see here, this is 5.3 if I round that off. Okay, so my triangle area formula, I have 1/2 base times height. So that's 1/2 times the base of 6 times the height of, well, rounded off, we got 5.3. So that's essentially 3 times 5.3, which I could do without a calculator. That's going to be 15.9, but you could certainly use the calculator if you wanted to confirm that. For this problem, I'm trying to find the area of this triangle, which happens to be an isosceles triangle. So in order to get the area, we need the base and the height. The base, well, this 7.6 refers to just this piece right here. Since this is an isosceles triangle, which we can tell by these two sides that are the same, that means that this altitude is splitting the triangle's third side in half. So this other piece here is also 7.6. So we can use that to get the base. But now we also need the height. To get the height, since this is a right triangle, I can use my Pythagorean theorem to find that height. So we've got a squared plus b squared equals c squared, my Pythagorean theorem. And I'm going to label this height with an h, just so I can refer to it easily. And now, using my Pythagorean theorem, I can say a squared, so I'll use that 7.6 for that, so 7.6 squared, plus b squared, so plus h squared, that's the other leg of the right triangle, the other non-hypotenuse, equals c squared, that's my hypotenuse now, 8 across from the right angle, so that's 8 squared. And I'm going to do this on the calculator, and I'm going to round this off to the nearest tenth. So I'm going to start by isolating h squared, which I have to do 8 squared minus 7.6 squared in order to do that, and that ends up rounding off to about 6.2, so that's the value of h squared. But now I need to take the square root of that. So back to the calculator, and let me do square root, and then let me just do 6.2 inside there. I'm supposed to round everything to the nearest tenth as I go. So So that comes out to about 2.5. So I have an h value of 2.5. My area now, that's 1/2 base times height. The base is going to be 2 of these 7.6s, because remember, this isosceles triangle has one of these on each side. So I'll write 2 times 7.6 for the b value. That's all the b value right there. And then for the h value, we're going to use that 2.5 that we just found. Okay, doing this on the calculator now. The 1/2 and the 2 actually cancel out, so you don't have to write all that. On the calculator, you really just need to do 7.6 times 2.5. And let me do that now. So plugging that in, I end up with about exactly 19. All right, that's our area. For this problem, I'm trying to find the area of this right triangle. So to do this, I need the base. Actually, I already have the base, but I still need the height to use 1/2 base times height. So let me use Pythagorean Theorem to find that missing height, because I already have 2 sides of this right triangle. I just need the third side. So a squared plus b squared equals c squared. C value in this case is going to be this 11. That's the across from the right angle. And then our a and b are going to be 6, and this other side here that I'm going to call h. All right, so I can write 6 squared plus h squared equals 11 squared. So 11 squared, that's 121. 6 squared is 36. Let me subtract 36 from 121 to get my h squared value. So that's going to be, let's see here, 85. There we go, 85. I am going to have to use the calculator, though. I was trying to avoid it, but I need to square root this. And they want the final answer and the intermediate stuff to the nearest tenth. So we got no options, calculator time. So plugging the square root of 85 in there to get that h value, I end up with about 9.2. Again, we're rounding off to the nearest tenth for the intermediate steps. And now I actually do have enough to find the area. So 1/2 base times height. So that's going to be 1/2 times our base that they gave us of 6 times the height that we just found of 9.2. So that's going to be 3 times 9.2, which I don't need the calculator. That's going to be 27.6. For this problem, I'm trying to figure out the area of this triangle. So to find area, I need the base and the height, so I can use it in 1/2 base times height. I actually do have the base already. It's this 12 centimeters here. The height, though, is this h that they're not telling us. So to find that, I can actually try using the Pythagorean Theorem, because this is one side of a right triangle. We've already got the hypotenuse of that right triangle. We've got this 10 here, and we could find another side down here. But let me write out Pythagorean Theorem, and then we'll get to that part. So a squared plus b squared equals c squared. Now, you might be wondering, well, what is this bottom side here that we can use as our second side? Because you always need 2 sides in Pythagorean Theorem if you want to solve for the third side. Well, this is an isosceles triangle. We know this because we have these 2 sides that are both 10 that are identical. Since it's isosceles, that means this altitude here is actually splitting your third side into 2 equal halves. So that means that this little side here is actually half of 12, so 6. So now I can plug 6 and h and 10 into this. So I can write 6 squared plus h squared equals 10 squared. And to get h squared by itself, I have to subtract 6 squared to the other side. So 10 squared is 100. 6 squared is 36. 100 minus 36 gives us 64 over there. And then h is just going to be the square root of that, which is 8. Well, we're not done yet. We just found the height, but we still need the area. 1/2 base times height. So that's going to be 1/2 times that base that they already gave us of 12. So careful here. They're talking about the base of the whole triangle, not these little half triangles. And then the height, we just found that. That's 8. So I've got 1/2 of 12, which is 6, times 8 is going to be 48. And they actually have units on this. So that's going to be 48 centimeters squared. On this problem, I want to figure out if this is a right triangle or not. To do that, I just need to see if these sides satisfy the Pythagorean Theorem. A squared plus b squared equals c squared. So for a and b, I have to use the shorter of the 2 sides, because this c is always our longest side, our hypotenuse. So I can write 73 squared plus 154 squared equals, and this is kind of a question mark, equals 170 squared. Let's use the calculator to see if that's true or not. So on the calculator, 73 squared plus 154 squared comes out to 29,045. Now, I have a suspicion that 170 squared is not going to come out to that. It should end with a 0 because the thing that you're multiplying by itself ends with a 0. But let's see what it actually does come out with, just out of morbid curiosity here. 170 squared equals 28,900. So actually not that far off, but definitely not the same number. Therefore, that tells us that this is not a right triangle since it did not satisfy the Pythagorean theorem. For this problem, we want to know if this narrow little triangle here is a right triangle, and the only way to know that for sure is to plug these sides into the Pythagorean theorem, a squared plus b squared equals c squared, and to see if it comes out the same on both sides. So for a and b, we always pick the shorter two sides because c is reserved for the hypotenuse, the longest side of the triangle. So we can write 19 squared plus 180 squared equals maybe 181 squared. Well, I guess we'll find out. Let's use the calculator for this. So on the calculator, 19 squared plus 180 squared, that's coming out to 32,761. And how about 181 squared? Well, if I square that on the calculator, that comes out to the same number. All right, well, that proves it. This is a right triangle. To see if this triangle is a right triangle or not, we need to see if the Pythagorean theorem works on this thing. So let me write out Pythagorean theorem. A squared plus b squared equals c squared. And for a and b, we pick the shorter two sides because c is the longest side, the hypotenuse. So we can write 111 squared plus 148 squared equals maybe 188 squared. So let's plug these two sides into the calculator to see if this actually comes out true. So here we are on the calculator, plugging that in for just the left side of the equation, and that comes out to 34,225. Now, I have a feeling that 188 squared does not come out to that because you're doing an 8 times an 8 for those last digits, which does not give you anything with a 5. But, hey, let's plug it in anyway just to finish this off here. So 188 squared, that's coming out to 35,344, so something different. Since these are not the same quantity, that means that no, this is not a right triangle. For this problem, I want to know if this triangle could be a right triangle. So to figure that out, I'm going to see if it satisfies my Pythagorean theorem, a squared plus b squared equals c squared. For a and b, I'm going to have to pick the shorter of the two sides, and then c is the longest since that's the hypotenuse. It's always the longest side of a right triangle. So I'm going to write 87 squared plus, and for b I'll use 116 squared, and it doesn't matter if you switch these two, it comes out the same because you're adding them. But now c squared, that has to be 145 squared in order for this to be a right triangle, or really any kind of triangle. So let's do this on the calculator and see if these two sides are actually the same. So I've got 87 squared, and let me delete that last thing, plus 116 squared comes out to 21,025. Okay, how about 145 squared? 145 squared, that comes out to 21,025. Well, those match up. This proves that yes, indeed, this is a right triangle.